All right. Hi, everybody. Thanks for showing up to another edition of our Solid Edge online training. This is the first episode where we're going to go into some of the new features in ST5. There's a lot. You may have seen the figure of 1,300 enhancement requests granted in ST5, and that could be anything from changing the color of a button right down to some pretty major operational changes. In this lesson, we're going to look at some of the assembly features, the new tools we have for working in assemblies and creating assembly relationships. Everyone here has had the link to download the activity files, so I encourage you to follow along. Again, this is going to be recorded, so don't worry if you fall behind. But the purpose of having that data set is so that you can try these out yourselves and kind of get a feel for some of the new features. So the first thing I'm going to do, I'm going to go into my open command, and I'm going to browse into my ST5 online training folder. So if you've unzipped the data set, this is what you should have once that's unpacked and placed somewhere where you can access it. And the first thing we want to go into is this relationship enhancement folder. And I kind of want to go through just some of the general enhancements they've made to some of the relationships, the assembly relationships. We're going to open up this key points data set. Now, if any of you attended our any of our launch seminars, this might look kind of familiar. I kind of joked when we presented this that it sort of looks like baby toys, but it's a good kind of conceptual way to explore these assembly relationships. So, very first thing, I want to kind of zoom in here and have a look at this cube here, which for some reason is named square, but we won't mince hairs. And what we've also got is we've got a sketch lying on the ground. Now, you're all probably aware that sketches placed in an assembly, and we can see it here in our tree, they can be used to position components. It's actually a really handy way of doing kind of quick layouts, especially then when you adjust the sketch, your assembly changes as well. So it's a useful technique. Now, we've made some enhancements in terms of making it easier to select the edges and key points of sketches. So I want to go and start the connect relationship. And there's lots of different ways to start assembly relationships. One of them, we can just click right in the type of relationship, and then it'll allow us to start selecting key points on any part. And as I kind of mouse over the parts, I want you to notice that we've added these little I guess the term for them is glyphs, but you see it's giving me that center point marker. We're getting a little bit better feedback as we mouse over key points where we didn't have that before. What we can also do now is we can actually select a key point of a sketch as the first part of the operation. This doesn't seem like a big deal, but before you actually had to start with a part before you could select an element of a sketch, and that was kind of counterintuitive. So what I want to do is I want to position this block by selecting the corner of the sketch here and lining it up with the midpoint of this edge. So I'll start again with the sketch, and I'm going to click once. And you can use Quick Pick to make sure you've got the right point. But once you've got that point selected, you see it's highlighted. And in our Smart Step, we've moved to the second part of creating the relationship, which is the target part. And now I want to find the midpoint of this edge here. And sometimes it's hard to pick up on the midpoint. My one tip with that, if you're looking for a midpoint, just zoom out a bit, because it gives you a little bit more granularity and you'll be able to find that midpoint. So I'm going to click that midpoint, and it's going to move my my cube over to that. Let's do that one more time. Let's line up the face of this part so that it's always touching this edge. So again, I can start with the sketch, which is new in ST5, and then I can pick up this face here. So, having done that, the next thing I want to show you guys is something we're going to be using throughout these exercises, which is the drag component command. It's up here on your home tab, and it's right here, drag component. What this lets you do is this lets you kind of move a part either along an axis or rotating it, or just doing what's called a free move. But what's unique about the drag component is that it will still respect assembly relationships. So to illustrate that, we're going to move this block along its degrees of freedom, or what degrees of freedom remain. So with drag component selected, I want to make sure that I'm in freeform move, which means it'll kind of just move anywhere in 3D space, providing that an assembly relationship is not constraining it. This is different from a steering wheel move, which will allow you to override or modify assembly relationships when you do that move. So we're going to be using this tool a lot, so just to get familiar with it, I want you guys to click on this, set the freeform move, and just click any part of the square and hold it down. And as you move your mouse around, you'll kind of see that it's kind of free to wobble on different axes, but it will maintain that key point locked to that, or that midpoint locked to the corner of the sketch, and it will also keep that face in some way lined up with this edge that we described here. So we'll be using this a lot. And of course, once you're done, before you exit the command, you can hit reset, and that'll just bring it back to the position it was in before we started the move. So I'm going to go back up to my select tool, which is a good place for home base, and I'm going to just zoom down here and let's have a look at some more features they've added. The first thing I want to do is I want to place one of these fasteners. It's kind of a lame-looking fastener, but you get the idea. I want to put it on the slot. Now, in mechanical design, we use slotted holes a lot. And for those of you that were paying attention during the launch events, you know that we've added a new slot feature to Solid Edge in both synchronous and ordered. What's nice about that in an assembly is that if we go and position this fastener in this slot, it will automatically pick up on the midpoint of the slot for us. So let's do that right now with an axial align. And I'm going to click that to start my axial align. And as I mouse over the cylinder of this, notice that our feedback is a lot better than it was in previous versions. You can actually see the highlighted face, but also the center line axis, and that kind of helps us orient ourselves. So I'm going to click that, and I'm going to bring it over here, and just as you come over the slot, you'll see the first thing it'll want to do is it'll show you that center axis right in the dead center of the slot. So I'm going to click to accept that, and you notice that now our fastener is lined up in the middle there. Maybe the last thing we want to do to fully constrain it is to just mate this underside face to the top face of the plate here. So I'm going to start a mate command, and I'm going to go over and just pick up that bottom face. Again, don't be afraid to use quick pick by holding your mouse still, hitting right click, and then you can make sure you've got the right plane selected. So I'll mate that with that, and that'll pop that down into place. So this is nice and handy because when you design a slot in a mounting plate, for example, generally the middle of the slot is your nominal location for your fastener. And now with the new slot feature and the axial line command, Solid Edge is going to recognize that. Another thing that's nice about the slot feature is it goes with this new relationship called the path relationship. And that's hidden in this button stack here. Remember that when you see this little downward arrow, that means there's more commands underneath. And there's the path relationship. And it's pretty straightforward. Before we start that, though, I'm going to stay in my mate command, or start my mate command, and I'm going to mate, again, the top face of this to, or sorry, the bottom face of my fastener to the top face. So you'll see, having done that, it's now lined up in plane with the plate. Now I'm going to go over and I'm going to start that path command. And again, that's kind of underneath the cam. It's in the button stack underneath the cam relationship. You'll see path relationship. And this is pretty straightforward. Basically, the first thing we choose is the follower. And in this case, it's going to be the center axis of our fastener. So I click that there. Now, it's going to ask for an edge chain. And you notice that if we mouse over the slot, and I'm going to use this curved one here just because it's cooler looking, it'll actually pick up on the center axis of that slot. Again, that's done with a slot feature, so Solid Edge is programmed to recognize that. Now when we click that and then go back up and hit check mark to complete the command, what you're going to see is it's going to drop that fastener in there at some point. Now, what's nice about the path command is that the fastener is unconstrained along this path, but if we go to the drag component, and again I'm on free move, as we click and hold and drag that, you're going to see that it will constrain that fastener to always follow along that slot. So we're going to look at this in a little more detail in a few minutes, but basically the outcome of this is you can get some pretty nice assembly and machine design relationships with the slot feature and the path command. Okay, back to my select tool. Let's take a look at something else. I want to show some more enhancements with our key point feedback, and we did show this in the launch events. But the first thing I want to do is I want to ground this donut part. I want this to kind of stay in place. And a grounded relationship, which is right here, what that basically says is it says I like where this is in 3D space, so fully constrain it there in space and don't allow it to be moved. So you'll see it'll get the little icon next to the donut when we start the ground relationship and select it. I'm going to go over to drag component now, and I'm just going to move this ball just by, again, I'm in freeform move, and I'm just going to click and drag it. Just position it kind of roughly over the top of my donut. Because what I'm going to do is I want to create a relationship which constrains this ball to sit inside this donut. Like you imagine like if we just dropped it in there. Easy in the physical world. It takes some assembly relationships here in the virtual world. So the first thing we're going to do is we need to line the center point of this ball up with the axis of the torus. And we're going to use a connect command for that. So I'll start my connect command. And you want to go over, and pretty much the first thing you're going to select is that center point of the ball. It'll even tell you in the little feedback that you got the center point. So that's our first point. The next thing we're going to go after is try to find the center axis of that torus. And as we kind of mouse over it, it wants to go to the center point, but we actually want the axis. So I'm going to right-click when I mouse over that ball to get when I mouse over the donut to get this quick pick menu, and you'll see axis is one of the things that shows up, and it gives us that nice feedback now. So if I click that, we can snap that ball onto the axis. So we're partway there now. Now the next part is a lot more straightforward. I'm going to click the ball. I'm going to go now to a tangent relationship. And a tangent relationship keeps a round edge in contact with a planar surface or another surface. So pretty straightforward here. We're going to select the ball, and then we're going to just select the torus. And it's really the only thing we can do. And what that's going to do is that's going to plop that down so that it's fully constrained in there. Now, if you're feeling adventurous, you can test this out by going into the back to the select tool and just jump into face select. And the way we do that is once you have the select command selected, I'm just going to jump down into face priority. And what this lets us do is this lets us pick up, instead of on parts, on actual features. So when we click on the torus, we get the torus callout. And when I click on that, I can actually modify the properties right here in the assembly environment. So if I change that minor diameter to 50, for example, my torus gets thinner, my donut gets thinner, I guess you could say. But notice too that once that change is made, the ball drops in just like it would. So it's a nice example of how we can constrain these things. Last thing I want to show you in this data set is some enhancements to the center plane command. What we're going to say is we want to, and before I go any further, I want to jump back to part priority. So I'm selecting parts, not features of parts. So again, that's in that drop down under your select menu. Click part priority. So what we want to do is we want to position this cone on top of this plate, but we want the cone centered on the plate, you know. Again, that's a concept that's pretty easy to grasp. We've got these edges here. We want it in the dead center. So let's look at some ways to do that. The first thing we're going to do is start a make command and pick up on just the bottom face of this cone. Again, use quick pick if you can't select it. And then we're just going to mate that to the top face of my plate. That's pretty easy. Now to center it, what I want to use, and you think about it, if you had a reference plane or something, you might be able to make use of that, but the center plane command, which was introduced in ST4, has continued to evolve. One thing we can do when I start that command, it's going to ask us to pick up on our target part here. And you can actually go in, and if I wait for quick pick to come up, I can right click and select the axis of that cone. And it gives us that nice feedback. Now the next thing I'm going to do is select the two faces that will center it. And notice that these aren't even parallel faces. They're actually, they're not parallel, but Solid Edge will still recognize and put that axis in the center point between them. Let's do that one more time. Again, starting with the axis. This time we're going to line it up on the other two faces. So I'm still in my center plane, center align command. And then I'm just going to pick the axis and then one face and then zoom around. And we don't have to spin around, by the way. We can kind of mouse over it and use quick pick to find that and then drop it in. So some enhancements to the center plane command. Now we can select axes of round or cylindrical features and line them up. Okay, so now we're done with this data set. I want to go in and close that and open up another data set just to show another application of some of the things we've learned, maybe a little bit more tangible. So again, I'm going to go into the open command, and I'm still in my relationship enhancements folder, and I want to open up this ring. Because what we have here is we have kind of a ball bearing design, and this kind of shows where we can apply some of this that we've learned. So the first thing I want to do is I want to grab both this sphere in the toolbar, and I want to also grab the ring. And you can hit space to enable a multi-select, so that when I reach up here, I grab that ring as well. And then with the two of them selected, I can right-click and do a show only. Because right now I only want to see those two. Now, something important to note is that this sphere in here, our ball in our race, is completely unconstrained. If we go drag component, you'll see that we can kind of just pull that right out. So how do we make relationships that will actually kind of hold that into where we need it to be? And here's how we're going to do it. The first thing we're going to do is we're going to line up the center point of the sphere with the center axis inside that race. So I'll use the connect command, and we've done this once before. I'll pick the center point there, and then as I mouse over, what you want to look for is you want to just grab that face in there, and it'll give you that feedback of the axis. And when we click to select that, that'll line up the center point of the sphere with the axis. Now the last thing we want to do is we want to snap it down into position, and you could use the tangent relationship, but the tangent relationship. But I'm going to use the connect command, and instead of picking up on the center point of the sphere, I'm just going to pick up on the surface of the sphere. So using quick pick, you see that I can toggle down to the surface of that sphere, and then what I want to connect it to is actually just the edge in here. So again, that's going to require quick pick. So if I right-click in there, you see as I kind of scroll down my menu, I've got an edge. So if you think about it, I'm telling it I want some part of the surface of that sphere to always be in contact with this edge. And that's in fact what's going to give us what we're after here. And that'll snap that in. So let's go back to our select tool now and show everything. And there's a couple of ways we can do that. You can just right-click anywhere in the design space and hit show all, and that'll bring everything back. And just to test how this works, we can click on a ball. And again, it can be any ball that we can click on. But before we do that, we want to go over to face priority, because what I'm going to do is I'm going to modify that ball. So within face priority, I can click on that feature. And if it's synchronous, it'll give me some feedback, in this case the diameter of the sphere. So clicking on that, I can change the diameter of the sphere, and we can watch as our relationships hold this all into place. So we've decreased that, but they're all in the right spot. Now, if you're wondering how this ring adjusted, take note that you've got these little linked symbols up here. And if you actually go in and edit this ring, in-place edit these two rings, you'll see that they're actually linked to the size of the ball bearing. And that's just done within an Interpart copy and some of the linked technology that exists in Solid Edge. All right, let's move on to another topic. I'm going to close this. And now we're going to go back into the open command, and this time we're going to jump back up a level because I want to go into my next folder, which is the rigid set command. This is a new command, a new assembly relationship introduced in ST5, and we're going to open up this trolley ASM. It's the top one right there. So have that selected and hit open. Okay, so let's take a look at what we've got here. We've got this kind of this frame, and it is in fact made using frame components in Solid Edge. And then we've got kind of a group of parts, and you see them down here. They're not arranged as a subassembly, and they're all unconstrained. You can see they got those wobbly lines showing they're completely unconstrained. Now, where we might see this is in the case of imported geometry. We might see this condition where we're designing this frame and we've imported this wheel design from another CAD system, in which case you're not going to get any relationships. Everything's in the right place relative to each other, but there's no relationships holding this together. So a nice quick way, and just to show you, if I go to drag component and pull on one of these, I can drag it all over the place. It's going to fall apart everywhere. So what we want to do is we want to be able to kind of say these guys are good where they are. We want to keep these guys held together and then continue to build assembly relationships based on that. So the way we do that now is with this new rigid set command right there. And it's pretty straightforward. Basically, it's just going to hold everything, parts together relative to each other, but still allow them to move in space. When we start it, you notice that we can choose what to do with shared relationships. That means relationships within these parts. We can suppress it, delete it, or ignore. In this case, there's actually no relationships between these guys, so it doesn't matter what I pick. But I'm going to put a box around this and hit check mark. Now, if we go in and look at any of these parts, we're going to see down here where our relationships collect that they've all got this rigid set relationship. And what it means is it means that any one of them I drag, the whole thing will come along with it instead of it falling apart. So now with that done, we can go and assemble this. And again, this is a nice way to put things together if you're dealing with data from other CAD systems where the assembly relationships don't come through with the parts. So I'm going to mate this face over here and then mate this face maybe up along this top part. Or actually, you know what, I'm just going to undo that, and we've actually got a pin in here that we can line up with one of these holes, so I'll do that instead. We'll line up that pin with that hole, let's say. But the point is that now we can work with this without worrying about it falling apart. Again, great for imported geometry. I'm going to go ahead and close that and then open up our next example. So back in the open command, we're going to go up one level into our main training folder here. And we're going to go to this path relationship. This is where things get really fun. We already looked at the path relationship before. I'm going to show you some more stuff we can do with it. And I want to start with this, this top one, this hydraulic cylinder 00 here. So select that and hit open. Okay, so when we last looked at the path relationship, we saw that you can use it in conjunction with a slot feature. And it will keep a part constrained within that slot but not allow it to exceed the edges of that slot. That's one function. In this case, we've got a cylinder, and if you think about a hydraulic cylinder, it's always got a stroke where it will bottom out on either end. And if we want to replicate that, we can do that with assembly relationships. Now, within the bore of the cylinder, someone has constructed a sketch line to kind of show us the travel of our hydraulic cylinder. And we can use that to build a relationship that will accurately simulate that. I want to go in and go into the path relationship, which again is in this button stack right here underneath CAM. So I'll start the path relationship. And the first thing it's going to ask me to do is the follower. Remember when we did this before, we picked kind of the center axis of a fastener. In this case, we can actually pick a number of things, but what I want to get is I want to get just the center point of that back edge of the piston. So if I kind of right click there, you can see that there's lots of different things I can pick with the quick pick. It's this center point right here that we want to grab. So we've grabbed that as our follower. Now the edge chain that it's going to follow, instead of picking a slot like we did last time, we can actually grab the sketch. And when we click that, what we're telling it is we're saying keep this face, within the confines of this sketch. So again, you can click the green check mark when you got that selected, or as veteran Solid Edge users will know, our right click will also do the same thing. Right click will accept the command and finish it. So we've done that. If I just go back to my select tool and we take a look at our shaft here, you see that there's the path relationship that's collected. And if you go into drag component and click and hold on that cylinder or on the shaft, you'll see that it will travel all the way to where the sketch ends and then not allow itself to progress anymore. So you pull that back and it's doing the same thing on the other side. So using the path command or the path relationship and a sketch line, we can kind of create any mechanical behavior we want. I'm going to leave this open because this assembly is a sub-assembly in another one, and I want to open that higher level assembly just with the open command, because now we're going to combine two of these relationships to get some really neat mechanical behavior. So in that same directory, you should see this next one here, number 2, the assembly pattern, and hit open. Make sure to leave this open in the background because we want it to remember that new relationship we created. So in here you notice that we've got one of these hydraulic cylinders positioned, as well as some bracketry, and then the whole thing's been patterned, I guess 6 times. So just zooming in on this guy, because this is our initial one we placed, what we want to do is we want to constrain the movement of this piston along this arc, this sketch that's been created in the assembly. And one thing you'll notice is that next to the cylinder, it's been set as an adjustable assembly. This is just done by right-clicking, going to Simplified Adjustable, and selecting Adjustable Assembly. And all that means is that the freedom of motion that it had as its own assembly will be available now in this top-level assembly. This is an important thing to note when you want to make this type of relationships. So because of that, we're going to place one more assembly relationship on this level, this top-level assembly, and it'll confine the movement of the piston along this, while at the same time taking into account the stroke length that we defined with the relationship beforehand. So we're going to start again with the path relationship. And before I do that though, like if I kind of rotate, I've got a 3D mouse going right now. If I rotate, you see I'm kind of rotating actually about the center point of the assembly. If you ever want to change your center point, just go into your, and you're using a 3D mouse, just go into the add-ins folder or toolbar here, and do the select rotation point, and just pick a point kind of closer to where you're working. Now when I rotate, I'm rotating about this part. So what we want to do is we want to start that path relationship again, and I want to pick up on the center axis. You don't want a point, you actually want the axis along here. So you're going to have to use Quick Pick probably, and just scroll through, and we just want one of these axes in here, because an axis is theoretically an infinite line, and we can snap it to this sketch here. So I'm going to pick up on this axis, and then again for my edge chain, I'm going to pick up on the sketch line, and then check mark to accept. So let's take a look at the mechanical behavior that we've created with this, and I'm going to use the drag component again. So I'm going to grab, again, this the shaft head here, and as we pull it in this direction, notice it's going to travel right until the very end of that sketch. It's going to bottom out at that sketch because that sketch or that path relationship is holding it there. Coming back the other way, however, it's not going to let us go to the end of the sketch, because if you look down here, the cylinder has bottomed out with that other relationship within the cylinder. So these two relationships are constraining our motion in different directions, and we can get that mechanical behavior. Also notice too that if I zoom out, because this is patterned, when I make a move on here, these guys are going to update as well. So that's an example of how the path relationship can give us sort of some complex mechanical behavior if we use it in conjunction with sketches. All right, we're going to close out of that and go into our last demo set here. I'd recommend not to save this, because when we launch the recording, you guys can go back and do these all again. So back into the open command, and up one level, we're going to go into our final demo set, which is the barrel cam. I'm going to show you guys how some enhancements to the cam relationship allows us to get a barrel cam type action. So first, let's do a little bit of review. Let's go into this camber and pin assembly and open that up. That's the top one within the barrel cam folder here. Okay, so first we're going to go into a bit of review about how the barrel cam works. Here we've got this pin kind of floating in space, and we want to position it over this cam to give us the kind of relationship that we're after here. So the first thing we got to think about is that this pin is kind of like offset. We want to line it up over the center point of the cam here. That's going to be our first method of positioning it. Then we're going to go and create a cam relationship, right, on this surface here. So the very first thing we're going to do is to create a new assembly relationship. First, I want to turn on this coordinate system so I have something to line up. And you can. Then I'm going to go and I'm going to start a axial align relationship to line the center point of that follower up with the center point of the cam, which is in fact that reference point. So I'm going to start the axial align command, and I'm going to pick just the center axis, and again we get that nice feedback on this part. And then I'm just going to go in here and just grab that Z axis just to position it over top of that cam. Now it may kind of jump down like this, but that's just because it needs some more relationships. So we can go to the drag component and just kind of pull it up, and it should only be able to move in that vertical axis because everything else is constrained. Now we want to line up this follower with this edge face, which will be our cam. So again, I'm going to start that cam relationship, and we're going to pick this round surface here as our follower, and then we'll pick this face as the face chain. Now, new to ST5, we've got some new options in what can be defined as our cam. Before it was just face chain, but we've got some other ones which we're going to look at earlier. But for now, we're going to use face chain because that'll let us pick up on that surface and snap our cam or our follower to our cam. So if we want to have a look at what this looks like, we can go over to the drag component again, and this time again make sure you're in free move, and we'll just kind of click and drag that, and you'll see we'll get that cam action, which is what we're up to, or what we were after. That's basically what we wanted in this new, or in the existing relationship. Now I'm going to close that out, and we're going to go into our open command again because we're going to look at some enhanced functionality now in ST5 with that same relationship. And I'm going to open up this second assembly, which is the cam.asm assembly. Okay, here we have what's called a barrel cam type assembly, and this is sort of this new enhanced functionality here in ST5 where this cam would rotate, and then these arms the pins would follow in that surface, making these arms give us some sort of mechanical motion. And we can now set that up using assembly relationships. The first thing we're going to want to do is we're going to select this pin, and we're going to want it to follow inside or made up with that inside track of our barrel here. So to do this, we're going to use a connect command to set up the relationship. So we want to start that command, and you want to reach in here and you want to pick just the center face at the end of that pin. Again, you can use quick pick to kind of scroll through your different possibilities, but it's this center point that we want. So if you can select that and then reach in. Now, by default, it's going to show you the center axis of the cam, and that's not what we want. We don't want the pin stuck to the center axis. Instead, we want to use quick pick here and find the outside surface of that inner track, not the outer cylinder, but that inner cylinder. And that's going to snap the face of the follower to that surface. Now, it's not in the right place right now because it still needs some more relationships, but it is adhered to that surface. So the next thing we're going to do is we're going to go and start our cam relationship again. And this is how we're going to define how it follows. So for our follower, we're going to pick up the outside surface of that pin, and then once that's selected, now we want to pick the track of this cut here. So we want to change our options to edge chain, and you want to pick up on just that outer edge of that track. You can actually do either or of these edges, but we want to pick this outer one just because it'll position our pin correctly. Our pin's actually kind of far out of the assembly, and if we pick the other one on this side, it'll snap to the wrong side of the track. So that's going to position that to follow along that track that's been cut into the barrel. Let's do that one more time on the other side. Again, we're going to start with a connect relationship on the center face. And you want to pick up on not the center axis of the barrel, but actually that surface. So you'll have to use quick pick in this case and just grab that outer surface there. That'll snap it down to connect with that. Now again, we're going to start up our cam relationship, and we'll pick the cylindrical face of that follower and then switch to edge chain and grab that outer track there so that it will tell it to follow that along on that track. So you see it snap those two into the right position, and there's a couple of ways we can actually simulate the mechanical motion. We can use the drag component like we did before, but you see there's a motor that's been placed in this assembly. A motor can be something that simulates motion rotating around an axis or linearly along an edge, but this motor's been placed in the center of the cam, so if we go to create simulate motor here and hit the play button, that's going to rotate that motor that's already there for us. and those relationships will come into play and give us that barrel cam assembly relationship. So using these new enhanced features, you can create some pretty complex mechanical action here with assembly relationships. So that's going to wrap up our training for today.